The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon. My name is Ben Roll. I am an application engineer here with Ally PLM Solutions. Today's Lunchbyte topic is going to cover flat pattern in sheet metal and Solid Edge. For those of you that don't know, we hold these Lunchbyte sessions once a month. They're designed to explore capabilities that are oftentimes overlooked inside of Solid Edge. We want these sessions to be informative and useful for you guys, so if you have any suggested topics that you would like covered in the future, feel free to shoot us an email and let us know what you would like to see. Same thing, if you have any questions about what we've covered, write those down and send them to us in an email, and we'll get back to you. Like I mentioned, today's topic is on the flat pattern capability inside of Solid Edge. So this topic is going to be a little bit shorter than the other ones. There aren't as many things to discuss. So what we're going to look over today is the file properties for sheet metal. We're also going to look over how to create a flat pattern and what options there are available when creating a flat pattern. We're also going to look at how you save that flat pattern out to a drawing and how you use that flat pattern in the drawing. So we're going to go ahead and switch over to Solid Edge. So here I just have a blank sheet metal template open. So what we're going to do is just go in here and create just a basic sheet metal part that we'll go ahead and flatten. So we'll go ahead and put in what dimensions we want for this. Change my view back. And we'll just go ahead and place some dimensions on here to control what we want these sides to be. We'll go ahead and pull out our tab, and then we'll come in here and pull down our flanges. Go ahead and give them the dimension that we want. Sorry, I didn't pick up my dimension right. Just go in and reselect the bottom of those tabs and pull them down. Alright, so here we have just a basic shape for our sheet metal part, and you can see if I come in here to Tools, I can choose Flat Pattern, and I can go ahead and just select the plane and the edge that I want to reference, and it just creates flat pattern just like that. If we look into the flat pattern treatments that are available, one of them over here is the formed feature display. So we can pick if we want the formed feature, feature loop, feature origin, or as feature loops and feature origins. So to display that, we'll go ahead and delete this flat pattern and go ahead and put in some features. Go back into synchronous. Alright, so we'll come in here and we'll put a few formed features on the face. That way we have something to look at and tell what's going on. So we'll go ahead, we'll put a few, put a few of those in. We'll also put a dimple here on the top. So we'll go ahead and we'll make a sketch of a polygon, place that on the top, and create our dimple. And we'll also go ahead, look in here on the underside. We'll increase. Put some gussets in there just so we have a couple more features. We'll also go ahead and pull out on each side some flanges that we would use for mounting that we can put some holes in. That way you can see how the holes behave in the flat pattern. So we have those. We'll just go ahead and put in some holes on each side. If it'll, okay, there it is. So we'll just put two of them on each corner of the flange, just so that we have a little bit more there to look at when we go ahead and flatten this. We're not really worried about where they're going. They're just kind of there to give you guys a general idea of how everything's going to react when you flatten this. So now that we have a few formed features and we have some holes in our sheet metal part, we'll go ahead and we'll flatten it again. So I'm going to go ahead and pick the same plane and the same edge. And you'll see I flattened it. All those formed features came over, with the panel that they were supposed to be on. So we can change how those formed features are displayed. For instance, if we want to change it to as a feature loop, we'll go ahead and we'll apply that. You'll notice that instead of the feature actually being there, go ahead and turn off that sketch to get it out of the way. Instead of the feature actually being there, it's just an outline of that feature. If we go into the feature origin, that's going to display the origin of the feature. So if you have a whole lot of features on there that you don't need to see, you can do that just to know that they're still there where they need to be. Or you can come in here to as feature loops and feature origins and apply that, and it will give you the outline and the origin. So if you have a large sheet metal part and you have a lot of formed features, maybe you want to use the feature loops. That way you know where those features are, but you don't actually have the geometry behind those features. So that's one way you can kind of slim this down to just being the bare minimum of what you need. You also have options here for outside corner treatments and inside corner treatments. So if we come down here to this corner, and we'll zoom in, that way you can see what happens. We'll go ahead and set the outside corner treatment to a chamfer, and maybe we'll say we want 5 millimeters. We can also set the inside corner treatment to a radius, and let's say we'll go ahead and, not 5. Go back into that, change that option back to 0.1. Okay, try it with none. Okay, so we went ahead and we applied the chamfer to the flat pattern. You'll notice if I go back to the synchronous model and I come down here and look at this edge, that chamfer isn't there. So that corner treatment is not going to show up in the 3D model, it'll just show up in the flat pattern. So it's there if you only want it to show up in the flat pattern, you don't want to model it as having the chamfer radius on the edges. So if we go back into our flat pattern, you'll see the chamfer is still there on the outside corners. We'll go back into our options. You also have the option to simplify B-splines. So if you have really complex geometry and you want to dumb that down to just lines and arcs, you can tell it to simplify it. You can set the minimum arc. So as it breaks those B-splines up into arcs and lines, this means that the minimum, the radius for the minimum arc is going to be 0.10 millimeters. Same thing for deviational tolerance. That's going to allow it to, when it simplifies, be within 0.10 millimeters of what it actually is. We also have the cut size default values. So if you normally use a standard cut size, you can enter that here and it will default to that. You can have it remove system generated bend reliefs. You can have it maintain the holes in the flat patterns. You can also control how it saves it as a flat pattern. So right now it's set to use the existing flat pattern, which means we've created a flat pattern, so it'll use that. It also says it'll use the folded model if the flat pattern is not defined, or we can tell it to use the folded model. So I'm going to go ahead and tell it to use the folded model, and we'll come back to that. What I want to show you right now is the cut size default values. So we'll go ahead and hit OK for those options. And if I come into the View tab, not the View tab, sorry, the Tools tab, and go to Variables, you'll notice if I expand the name of the variables, we have the flat pattern, model cut size, minimum for X and Y. So that's that value that you would have set in there as the default minimum, or sorry, the default cut size. We also have down here at the bottom is the flat pattern model cut size. So that is what the size of the actual flat pattern is that you need to cut out in order to make this part. So what we're going to do is we want to go ahead and call that out, that cut size out on the drawing. So in order to do that, inside of our sheet metal part, what we have to do is expose those variables so that they can be called out later. So we'll just go ahead and expose those. That way we don't have to, look in our model, figure out what the cut size is, and then type it into the drawing. We can go ahead and automatically call that information out in our drawing. So that's a real nice feature that Solid Edge has. So now that we have that exposed, we'll be able to call it out in the drawing. The other option we have is that save as flat. So you've created your flat pattern, now you want to save it out to a drawing. So when you come in here to save as and save as flat, if you remember in those options I checked to use the folded model. what that means is when I go to save it as a flat pattern, it will fold the model back up and ask me to create the flat pattern that I want to use to save out. So I can just use the same surface or same face and same line that I did to create the other flat pattern, or if I want, I can use a different one. So I'm going to go ahead and use the same one I used before, and you'll notice when we save it out, we can save that flat pattern out to AutoCAD or to a part or to a sheet metal document. So I don't really need to save it out, but those are the different formats that you can use. The other option we have, which we want to talk about, is calling out that cut size. Actually, sorry, there's one thing I forgot to mention. This last little option button here for the flat pattern is the size options. So here it lists the current size for the model, and it also has the option to set an alarm for the length and the width, or to use the default values. So for us, the default values are just 0, but you could set an alarm for that and then tell it not to use the default values and type in your own. So what we can do is type in, let's see, for our X, we'll just type in 900 millimeters and hit OK. And you'll notice if we look over here, it's giving us a warning that our part, the flat pattern for our part, indicates that the sheet size is, if I hover over this, is the 946.36 millimeters, but we told it that our maximum value is 900. So it has a little red exclamation mark over here letting us know that. So I'll just go ahead and I will turn those alarms off and set that back to default. And now we'll go ahead, we'll save this as our sheet metal part. We'll go ahead and save that, and now we'll create a drawing of that. So we'll come in here and create a drawing of the current model. We'll go ahead and run the drawing view creation wizard, and we're going to go ahead and, because we have the flat pattern saved in our model, we can choose to use the flat pattern. Go ahead and hit next, and we want a top view for this, and we'll just place that top view. We'll go ahead and increase the scale a little bit, make it a little easier to see. So now that we have that in there, we can create a call out for the cut length. So we'll come in here to our call out. We'll say cut length X is equal to, and then we'll come in here to our, to our property text. We'll click on that, and we want the named reference for our sheet metal part. And here you'll see that flat pattern model cut size that we exposed in the 3D model. So we'll go ahead, we want X for that. Say OK. And then we'll come down here and say cut length for Y is equal to, and we'll do the same thing. We'll go back into our property text and we'll change it to indexed reference and select the Y value. And you see a previews here. We'll hit OK for that. We'll go ahead and we'll turn off the leader. That way we just get the call out itself and not the leader line attaching it to anything. Just to make this a little bit easier to see, we'll go ahead and increase the text scale. So see, once I place that call out, it's automatically called out the X and Y cut length for the sheet of sheet metal that's needed for this part. That's all we really have as far as flat pattern in the sheet metal environment. I want to thank all of you for your time. I hope this session was informative and you guys learned something. If you have any questions or suggestions for future topics that you would like to see, here's our contact information. We have replays of all our lunch bites. You can get to them through our website, or you can go out onto YouTube and find them. If you have a smartphone and you have one of the apps to read this barcode here, we have the barcode, you scan that, and it will take you to our website so that you can find those replays. Once again, if you have any questions or suggestions, feel free to contact us. I'd like to thank you guys again for your time. Have a good afternoon.